Hello, everyone. My name is Larry Sharp, and I'm one of the application engineers here at Chroma System Solutions. And looks like we have a pretty good turnout today, so I want to thank everyone for joining us today. And just let you know that during these difficult times, our hopes and prayers go out to all of you, and I hope you're all doing well, you and your family, friends, co-workers. So today I'm going to be covering regenerative grid simulators, and we'll go into some discussion about how they work and the definition of what a regenerative grid simulator is. And I'll try to quickly cover a few applications where we use these. But if there's any detailed information you want to know, please contact us. I'm putting up my email address as well as at the end our sales address for contacting our sales group and our website. So we'd be more than happy to give you more detailed information than what I'm going to be able to supply in the period of time that we have today to cover this. So Chroma offers a wide variety of products, not just regenerative grid simulators, but AC sources, DC supplies, electronic loads, all the different things that are required for testing what we refer to as power conversion devices. We also offer electric safety equipment for high pot testing, impulse winding testing, even battery insulation testing for battery cell insulation. Passive component testers, LCR meters, battery cyclers, simulators, and then of course we integrate all of our equipment and other equipment into a complete automated test system with our own proprietary software. So today with regenerative grid simulators, I thought I'd start with a try to explain what a I even have trouble saying it, a regenerative grid simulator is. So a regenerative grid simulator does pretty much as the title defines it to do. Regenerative means that it has the ability to put power back onto the grid. And a grid simulator means it can simulate all the good and bad things that can happen on an actual utility power grid, which incorporates things such as the normal operation for a nice, clean sinusoidal waveform with a low output impedance source. But it also can simulate the various bad things that occur, various types of power line disturbances, and various interrupts that occur, including things like harmonic distortion and interharmonic distortion. A lot of devices lately have been popping up for what we refer to as microgrid distributed power generators. And what these are various ways of power being put back onto the grid from smaller, more localized power generation. And this can be done through solar and wind and even natural gas type generators. But it also includes things such as energy storage systems. More and more you're seeing that backup systems are being produced using batteries and fuel cells. And these also have the ability to be integrated back onto the grid to give power back to the grid. It also is popped up in electric vehicles. We're seeing vehicles coming up with what's called V2G, vehicle to grid connections, and these occur to give power back to the grid under various peak power times or various types of small interrupts and brownouts, those types of things. And all of these things have to be tested, and the testing for these has been defined by various standards, which we'll try to cover a few of those for you today. There's so many, it'd be hard to cover all of them in this time that we have. So our regenerative programmable grid simulator does just all of those things we just defined and more. So we'll be getting into that with you shortly. So when we talked about the distributed energy systems or various types of generation of power out there on the microgrid, we talked about solar and wind and electric vehicle, but there's also uninterruptible power systems, UPSs. And nowadays with what we're seeing with the medical industry being really taxed with the coronavirus, I'm sure uninterruptible power systems are becoming more and more useful, especially for the medical industry. Lab and real-time simulation. This is where they do real-time simulation for power, and it's referred to as PHIL or HIL, which is power, hardware, in a loop. We'll talk about that briefly as well. The makeup of the microgrid probably is something that I overcovered here, but originally when the R&D groups developed our 61800, they were focused on just the solar power and the PV inverters, what we call photovoltaic or PV inverters. But it's expanded now, as you can see, with wind energy, solar, EVSEs being bidirectional, putting power back onto the grid, and of course, energy storage. And some of the standards for that we'll get into in more detail. Standards such as UL 1741, IEEE 1547, and IEC 62116. These are all standards that refer to PV inverter type or inverters that put power back onto the grid. And there's various test requirements, anti-islanding, low voltage ride-through. They have to see their susceptibility under different power line disturbances, how they respond. Harmonic distortion, both how they respond to harmonic distortion and also to measure to see how much harmonic distortion they're putting back out. And all of this is done for the response and to see how they operate under those conditions. So in order, other things that cover the various equipment that we can test includes things that aren't grid tied. You know, as a source, you can use this to cover any type of device that gets its power from the grid. EV charging stations, large server power, telecom power, UPS interruptible power systems have to be tied to the grid. Large appliances, even HVAC, transformers, switchgear, even AC motors can be tested using this equipment. And as an option, we've offered a regenerative programmable load. And with that, we can do generators that are not grid tied to apply a load to that generator to verify it works over a full range of power requirements and different variations and loads. Transformers, switchgear also work as a source tied to our load, and we can load their devices up to verify how they work up to their full power range. So just about any device that's plugged into the grid would require a load in order to fully test it. And the option of having the regenerative load makes it a great device. Being regenerative and putting a lot of that power back on the grid makes it more efficient, so you're not dissipating as much heat or power internally in your facility. So in order to do that, our units have to operate in what's called a 4-quadrant or fully regenerative AC power source. And for those of you that don't understand it, the 4-quadrant, it basically defines which part of the quadrants are used to either operate as a source or sink power and put that power back onto the grid. So in simple terms, our unit operates in sink when it's operating in the second and fourth quadrants, and it operates as a source when it's operating in the first and third quadrants. If you'd like more information on what 4-quadrant regenerative source is and how that works, let me know. Reach out to me with an email, and I'll be happy to give you a little more detail on it. So in order to also do testing, our units have to simulate various waveforms and transients and various what we refer to as power line disturbances. And built into this unit, an internal digital signal, high-speed digital signal processor, which gives us that capability of doing all of these various programmable voltage changes and waveform changes. The unit itself, we have 4 models that range from 30 kVA up to 105 kVA. They can operate with a single phase output or 3-phase output, and currents all the way up to 420 amps RMS, 140 amps per phase when you're operating as 3-phase mode. Again, 3-phase, single-phase operation, easily configured. From the front, there's a button to press. It asks you if you want to operate as single-phase or 3-phase output, and selecting that, it will direct everything in single-phase to the second phase on the terminal block, and you can use that as your single-phase output, or it'll give you 3-phase output for all 3 phases in both Y and Delta configurations. Voltage on this unit goes all the way up to 330 volts line to neutral, gets you up to 579 volts line to line, and it operates not operates, but we also have options to increase that voltage for various different devices that you may have that need the higher voltages. And those go up to 400 volts line to neutral, 690 volts line to line on the 30 to 60 kVA units. And on the 105 kVA unit, we can go all the way up to 500 volts AC line to neutral, get you up to 865 volts line to line. And then there's even options more if you need to even go higher voltages. We can actually put these units in series, get you up to some extreme, some amazing higher voltage outputs on this unit. It has 4 standard interfaces, come standard on the unit: GPIB, Ethernet, USB, RS-232, and we also, as I mentioned, offer the regenerative programmable load. When it's because of the 330 volt line to neutral standard product that we offer, it gets you well above the typical units out on the market that go to 300 volts. The reason we do that is that 480 volts, when you're testing a 480 volt device and you need to test it at 10% power, it requires that you go to a higher line voltage, line to line voltage. 330 volt line to neutral is going to get you that higher line voltage that you need to get to test the upper end of the 480 volt range. 400 volt, as we mentioned, is another option. But the other thing with the extended current that we offer on these devices, and you can see in the graph here that I've put, that here we have on this one, is it extends the capability of total power and maximum power beyond most of what our competitors are doing presently. So because we can do higher currents at lower voltages, you can still maintain the full power rating of this AC source while you're doing the testing at the lower voltages. And even as that decays or decreases down to some of the other voltages, we still maintain a much higher power level at each of those voltages than some of our competitors. The unit has a great display, and the display gives you a lot of information. It gives you your set parameters as well as your measurements. It also has hotkeys that take you into all the different screens for setting up things such as system configuration, various parameter settings, various displayed measurements, and even access to all the advanced features that we're going to cover on this unit. And it also includes a waveform viewer, as you can see here in the bottom screen. It also has a great little numeric keypad, function keys to get you in and around and guide you through this operation of the unit. And most of the things I'm going to talk about today can be done either manually from the front of the unit or definitely through the programmable interfaces and using our software. The key feature, another key feature is, of course, the measurement capability of this unit. It has basically 12 different measurements that we can do with this unit. Accuracies are great. We're looking at 0.1% of the reading plus 0.2% of full scale true RMS AC voltage measurements. We can also measure peak voltage and peak currents, and we can also do true power, apparent power, and reactive power measurements as well. So a great device for capturing all of the information and for setting up and measuring your outputs. When we talked about 4-quadrant, just to go into that a little more detail, is that if you look at the waveforms on either side here, when it's operating as a source, it's outputting power to a load. That load can be, like we talked about, a variety of devices. Anything that plugs into the grid and pulls power from the grid pretty much can be powered by our device as long as it's within the maximum power rating of our device. So that gives you voltage and current outputs that are typically in phase. It will handle a wide power factor because it is regenerative. You can do a power factor of 1 all the way down to a power factor near 0. The other thing is when this unit is operating or sinking power, it will give you a waveform that looks similar to this because the current shunts or the current sense transformers that we use internally will actually are directional, and so when power is going back to the grid, it'll appear that the current and voltage are out of phase. Another way we indicate that regenerative power or power going back to the grid is that we put a negative sign in front of the power output readings, and also the power factor gets a negative sign when it's going in the opposite direction when we're putting power back to the grid. One application for testing is, of course, inverter testing, PV inverter testing to be specific. PV is a photovoltaic inverter used in the solar power generation. It's the device that takes the DC power from the solar panels and converts it into AC, and then does the synchronization to be able to actually put power back onto the grid. And there's several tests for that, and the tests are defined in standards such as UL 1741 and IEEE 1547. There's recently been some changes and upgrades to those that include what they refer to as the UL 1741 SA and the IEEE 1547 2018-2019 standards. These have added tests such as anti-islanding. Anti-islanding is a test that has to be performed to ensure safety for the grid, that when the grid does shut off, that after a certain period of time, the inverter will also shut power off and not continue to supply power to the grid. One purpose of this is just to protect the guys, the linemen out there working on the grid. Another thing that it does is it does something called low voltage ride through, high voltage ride through, low frequency and high frequency ride through. And what this does is this basically allows the inverter to continue to operate and to supplement or to support the grid even when the grid has some variations or low voltage drops due to, heavy loads under peak power times or something of that nature. Also, it has some tests for ramp rates. There's a specific ramp rate time for how fast power can be ramped up and put back onto the grid. So all of these things defined well into these standards. Chroma offers the perfect source for that, which is our 61800 regenerative grid simulator. It may have to be incorporated with a few other devices to make a complete test system, but we can also help you with that as well, because we have in our group a great group of design engineers that do custom systems for fully automated testing. The other application we refer to as the EVSE, which is the Electric Vehicle Standard Equipment device, which most people refer to it as the charging station. But this device does a lot more than just charge. It also protects the EV during different conditions of the grid applied to it. So with this, there are some standards like UL 2231 or SAE standard J1772. And in these standards, they define specific test requirements to verify that the unit under various line conditions will operate properly, and it'll do certain types of things to protect itself within a certain period of time. So those things are well defined, and we can do those types of tests with our 61845 or 61800s in general, all the product lines for the 61800s. We can also produce things like power line disturbances, which we already spoke about, interharmonic distortions, to see how the unit responds. And in most recently, in the last year or two, we started to see more and more applications where they're adding what they refer to as V2G. That's vehicle to grid applications. This is where the onboard charger for the electric vehicle or even the offboard charger for the electric vehicle becomes bidirectional, meaning it can not only charge the batteries, but it can take the power from the battery, convert it into AC, and put that AC power back onto the grid. So in order to support that, we use the 61800 grid simulator, and it's a perfect tool for that. And it also has the ability to put that power back onto the grid. The other application is what we refer to as real-time simulation. And what this is you've probably heard the terms hardware in a loop or power hardware in a loop. And that's where they take and simulate all of these different occurrences and variations and devices and test devices. And they need to do that with both grid power. And so our unit can actually be your source for real-time simulation. And we do that by using the analog input or external voltage programming that goes into each of the three-phase inputs on the back of the unit, and these will control the unit proportionally. It's a plus and minus 10 volt signal, and it controls the output such as like it's a big power amplifier, so that the output would be controlled to full scale. So 0 to 10, 0 to full scale on the output. The other thing great about this is the engineering group, our R&D guys, have made it so that this timing between the time you inject a low voltage input to control the unit to the time it actually controls the output and the output changes is in less than 100 microseconds. Matter of fact, in our 105 kVA unit, it's less than 70 microseconds, which is incredibly fast response. So from the time we change the voltage using the analog input controls to the time the output changes, less than 100 microseconds. So this is a device that's used greatly with arbitrary waveform generators to create various signals, or it can also be used with various data controllers that are used with hardware in a loop and power hardware in a loop, where they can actually record and simulate real-time data and put it into our unit to simulate those variations in voltage, frequency, waveform. And so those are things that we use for hardware in a loop and power hardware in a loop. Two great customers we have, which have been kind enough to let us use this information, is the Idaho National Lab. They even have a nice white paper out there that talks about what they're doing at the Idaho National Laboratory. Another lab is the Battery Innovation Center. They are also using our 61860. A great group of people in both of those. We have some of the best customers around, so we appreciate them. Power line disturbances, we've already discussed or mentioned it briefly previously, but I put this screen up just to kind of let you know what those are and where they're defined. There's a standard, IEC 61000 standard. There's various parts of that standard that define different types of power line disturbances. those can be transients. They can be impulse transients, which mean they're a sudden spike in voltage. They can be oscillatory, meaning they cause oscillation in the waveform. The waveform is not a nice clean sine wave. So when we refer to as clean power, power that doesn't have those types of variations in it. Voltage sag, this is where, like a brownout condition, this is where voltage will drop for a short period of time. Voltage swell is when the voltage rises for a short period of time. Under voltage, over voltage, similar. And then it has very short interrupts or various timing interrupts. And then it can also have noise or notches, they refer to in some cases. Harmonic distortion, which we'll talk about a little more, and frequency shifting. It can even vary its frequency slightly when it's switching. So these kind of things have to be confirmed that the susceptibility of the equipment that's being tested will not be damaged, but actually will either ride through these conditions or that it will properly protect itself when these things occur. So I mentioned that we can do all of these things manually from the front of the unit, and most of them we can do, but we also offer a general user interface. It's referred to as a soft panel. It's a LabVIEW executable standalone software. You don't need LabVIEW to operate it. And it gives you all of the programmability and gives you the controls to use all of the advanced features on the 61800. It also gives you the ability to capture all the data in a report generator, and it also gives you some capability of doing things like the synthesizer waveform editor, where you can create some very unusual waveforms. This is one of the usage of that I use, and it's a great tool. This is what we refer to as programmable sequences. With this, you can do very small sequences or very large sequences over a wide variety of time, or you can do it in time or in cycles. So, for instance, if you wanted to program a cycle, a single cycle in one sequence, you just nearly set the cycle time to 1. You can do everything down to 1/10 of a cycle and all the way up to hundreds, even thousands of cycles. So each of the sequences can be different, different amplitude, different waveform, different frequency. It can also, even when you're doing 3-phase, have different phase angles between phase shift between the 3 phases. And so you can independently control each phase, or you can control all 3 phases together as well. So I did a little quick test here. You can see the waveform here on the scope capture here on the right side. So we did a harmonically distorted sequence 1, drop out sequence 2, raise up to a lower voltage sequence 3, and on sequence 4 we're back up to normal. So there's all these different things that you can do, and this is not even close to the timing and the variations that you can program using this. The other thing you can do is what's called pulse mode. This is where you can create and inject a small interrupted time. You can do it at different voltage levels, even at different frequencies. You can do it at multiple counts or single counts. And you can do things like this, where you can create a simple notch out of the waveform for a certain period of time. So a very great tool for again, doing power line disturbances. We talked about the IEC 61000. The nice thing about this particular software package is we've incorporated those standards for voltage dips and interrupts and what they refer to as distorted waveforms, like flat curves where it clips the peaks, various frequency and harmonic distortion, voltage fluctuations. All these things have been built into our software and per the IEC standards. So it makes it easy for you to verify and test based on the standard requirements. You can also do user-defined, where you can go in and modify each of these tests to your own requirements. Another thing that we've mentioned on there is that we do harmonic distortion. We can do waveform synthesizing, and I seem to be missing my waveform synthesizer screen. But basically, as a synthesizer, we can create waveforms. You can even download waveforms from an Excel spreadsheet. But here you can also measure those harmonics. You can measure the harmonic distortion generated, or you can measure the harmonic distortion coming from your device under test. It gives you up to 50th harmonics. It allows you to view it graphically for each of the harmonics by their amplitude or by their percentage. And it also gives it to you in numerical value for each one of those particular harmonics. You can do it for 50 and 60 hertz fundamental frequencies. You can do it continuous if you're charting or graphing it, or you can do it as a single capture like I did here. It also gives you a total harmonic distortion measurement, as well as voltage, current, power, frequency, power factor, and volt amps as well. So all of these things add up to being, a remarkable source with incredible programmability, and all of that I have to give thanks to our wonderful R&D group that developed and created this. So the other things that come up is our optional AC load. When you're testing a device that is driving another device, it has to be tested fully under different conditions. Using our programmable AC load, we have the ability to do it in different types of rectified mode, constant current, constant power. We can also set different, what we refer to as crest factors. If you're familiar with crest factor, it's a high peak with maybe a shorted duration of time within a cycle. So we can do that very easily with our front panel controls built into the unit, and you can also control it from our software. It also includes constant resistance mode, which makes the unit look very much like a resistor. As the voltage increases, the current will increase proportionally, and you get to set the value in ohms. For constant power, the setting parameters are in watts, and for constant current, the parameter settings are in amps. We also have built into the AC load feature the ability to control the phase shift between the voltage and the current to create leading and lagging phases, current phase, to simulate pure inductive and capacitive loads. Great tool. Most, if you have a non-regenerative or a load that doesn't operate in all four quadrants, you wouldn't be able to do this, because here we actually are creating a voltage and current that are out of phase from each other when or a current that's out of phase from your voltage when you're supplying power to us. And so this is referred to lead and lag. If you're familiar with inductive and capacitive loads, capacitive current leads, inductive current lags, and it creates a power factor when they're out of phase from each other. And so we can create that. We can do it in single degree increments, and you can program that very easily with our manual controls on the unit or with our software. Another feature that we have is we refer to as extra high voltage. When the units we have, on the standard units that go up to 60 kVA, have the option to go to 400 volts line to neutral. But if you want to increase even above that, you can put two units in series to give you 800 volts line to neutral. So this is giving you a line-to-line voltage of up to 1,385 volts. You can also do this with our 105 kVA unit at even higher voltages. So if you have a high voltage requirement and you're finding that most AC sources out there on the market can't meet those requirements, give us a call. Let us know. We'll get in touch. We'll give you information to tell you how this is worked out and how you can put these units in series to do that. We'd be happy to help you with it. I know I've gone through this quickly. I'm opening it up to questions right now. We didn't cover too much detailed information in this presentation. Feel free to reach out to me. I will be more than happy to go into more detail on any one of the things that we presented, whether it's an application or the function of the unit. So give me a call or reach to me. I've got my email address here, Larry S at chromausa.com. And we also have you reach out to our sales at chromausa.com and our website. Join us on our website, chromausa.com. Or you can call us at 949-600-6400. So we'd love to help you any way we can. We're always interested in hearing new requirements, new applications. Feel free to reach out and give us any type of information or ask any questions that you have of us, and we'll be happy to support you. Thank you all very much. It was great having all of you here online with me. I'm opening it up to questions. Feel free to log in. I've also got the chat open, so feel free to jump in on chat. Thanks again.